Hello and welcome to the second episode of the Daily Data Science series. And today we will be going over certain applications of data science. So let's get started. Now, what are some of the use cases that come to your mind when you think of data science, right? Now, I'm showing certain applications. Let's think through what these are. The first application is home value prediction. In the US, there is an application called Zillow that impacts about 110 million homes, where the goal is to predict the home value, the value of a house in dollars, based on factors like its neighborhood, right? The locality, what size of the house it is, how many bedrooms there are in the house, right? The furnishing, and so on. So there are a lot of parameters, but the goal eventually is what price tag should you put on that home, right? And this is one application of data science. Another application could be a conversion rate prediction. So this is very useful for e-commerce companies where they are trying to predict what is going to be the conversion rate of certain key buying actions that users are expected to take. So if a user comes on your website, you can have certain key buying actions listed down that they should click on certain items, like they should probably click on the menu, they should look at a certain category of a product so a key buying action can be fulfilled. They should probably click add to cart at least once, right? So that can be another key buying action, and so on, right? They can click on buy, for example, that is another key buying action. So a conversion rate prediction is basically dealing with, are the customers who are visiting the website actually getting converted, right, in the purchase journey, right? So the purchase journey can be whether they are looking through products, whether they are adding it to the cart, whether they are clicking to buy and they're finally making the payment, and so on. Another kind of an application of data science is the drug response prediction. When pharmaceutical companies are creating drugs, right? When they're launching a new drug into the market, what is going to be the response of that drug, right? This could be in terms of how many sales is that drug going to take in the market, how much market share is that drug going to take in the market, right? So the response of that drug as well. Now, if you think what is common in each of these three use cases, the first thing that is common is that the value that we're trying to predict, right, is continuous in nature. Now, what do we mean by continuous value? If you think about home value, which is the target that we are trying to predict in the first case, the home value is continuous in the sense that it can be any value, right? It can be $100, it can be, let's take a more realistic value, it can be $100,000, it can be 100,000, probably $500, and so on. So it has a continuous value attached to it. Similarly, if you look at the conversion rate, it can be any number, right? It can be 11.8, 12.1, and so on. There is no restriction. It is continuous in nature. Similarly, the drug response can be continuous, right? How much market share is that drug going to take in the market, or how much sales is it going to get in the market? Now, dealing with this kind of a prediction where the target is a continuous value falls into the subfield of regression, right? This is an official term that we are introducing called regression, where we are using data science to predict continuous values, right? Now, there can be a common confusion that regression is referring to linear regression, which is an algorithm that we might have all learned about, right? But in this case, what we are referring to regression is a larger subset of data science problems which deal with predicting continuous values, such as these three. So that concept should be very clear. Now, let's think about specific industries, right? Let's take manufacturing, for example. What is a possible data science problem, which is a regression problem in manufacturing? Anything that comes to your mind? Okay. One interesting use case, now that you have had the chance to think through it, if you have not already thought of it, the very popular use case is predictive maintenance. To predict when is a machine likely to fail, right? When is it going to be its downtime? So if you're trying to do predictive maintenance, the input data that you're dealing with is sensor level data in your smart factory, etc. And you're trying to predict when the machines are likely to fail. So you're trying to predict when would you need to maintain the machines, and this will likely improve efficiency and reduce the downtime. Let's pick another industry like insurance. Any use case that comes to your mind where we are predicting continuous values using data science in insurance? This one will be very close to what you do in your day-to-day life, right? The premiums that you are actually paying for your different insurance, like if you have a car insurance, right, there is a certain amount of premium you're paying. That if you have health insurance, there is a certain amount of premium paying. If you have home insurance, right, again there is a certain amount of premium you're paying. So how do the insurance companies actually come up with that premium number that a customer is expected to pay at a regular basis? It is using data science, right? And specifically, it is using this subfield called regression within data science. So this is the first subfield of data science that we have talked about, and we have talked about certain use cases as well. Now let's look at another set of applications. Now, these set of applications deal with another subfield, and we will slowly come to that. But let's first go through these. Fraud detection. How do financial companies actually identify fraudulent transactions as and when they occur with the minimum latency, right? As quickly as they can actually identify it. So they are looking at parameters like what is the content of that transaction, what is the name associated with that transaction, what is the value associated, right? What place and time did that transaction take place, right? Was it from a known mobile number, phone number, or was it from an unknown phone number, and so on. And they're using a lot of other parameters as well, right? And they have gone very advanced. But the goal is to predict, right, whether that transaction is a fraud or it is not a fraud. So it's a binary kind of a prediction in this case. Remember, this is very unlike what we just discussed, which is a continuous value prediction. This prediction is a binary value prediction, whether it is a fraud or it is not a fraud. Another use case could be malware prediction, right? Given the current state of your computer or of your tablet, etc., is there a malware in your system? Now, this is another very powerful use case which companies use, right, when they are actually designing and selling their products to customers like us, right? Malware detection products, right? They're trying to predict whether there is malware or not as well, right? Because malwares are getting more and more sophisticated as well. So the companies also are resorting to data science to actually predict malware. Now, again, the target in this case is whether there is a malware or there is not a malware. Another very interesting use case that has recently come up is commercial aviation fatality prediction. Now, this is a mouthful, but what we mean is in commercial aviation, right? If you're taking a flight, right? Let's say you're taking Delta Airlines or you're taking Indigo or you're taking any commercial flight, to reduce the fatality rate, right? Even a very, although the fatality rate is also already very small, but to reduce it even further, what the companies are doing is that they are putting cameras in the cockpits and they're monitoring the facial expressions of pilots, right? So a pilot is always under observation, but what these cameras are capturing are the facial expressions, and behind the hood data science is being used to predict the likelihood of a fatality being occurring, right? For example, if a pilot is very tired or it's looking dull, right, compared to what his or her normal state is, right? So you always have to factor in what their natural state is, and then see with relative to that, are they looking more tired, dull, or are they looking energetic, excited, and so on. So monitoring that set of expressions, you're trying to predict the likelihood of a fatality occurring or not, right? So again, you're trying to predict kind of, yes, it is more likely for this flight to be fatal, or it's not likely, right? Based on your historical data. Now, again, the target here is yes, it is going to be fatal, or no, there is very less likelihood of fatality. Now, these use cases, which have this kind of a binary output or a very well-defined class-based output, right? So we have talked about binary outputs, but it could be the case that you are trying to predict, right, the different levels of fraud. So in the first case, you're trying to basically classify what severity of fraud is that transaction likely to be, right? Is it going to be less severe, medium severe, or very severe? Let's say you're trying to predict the grades of severity. It will be a multi set of classes that you are predicting. That will also fall under this set of problems, which is called classification problems. And they are used to predict what is formally called categorical values, right? Categorical values basically means you're predicting categories of values. Either it can be 0 or 1 like binary, or it can be multi-class, right? Any sort of categories. But if you're dealing with categories, you're dealing with a classification data science problem. And again, classification is a formal subfield of data science. We'll talk more about this, right? How these problems are solved later on. Now let's come to specific industries and try to think how are these performed in certain industries. Like what happens in finance, right? So finance, one more use case is credit scoring, right? How do you actually assign a credit score to a particular user, right? And that can be based on historical transactions, etc. In automotive, let's think about any use cases that come to our mind that deal with categorical values. Self-driving cars, right? A car has to identify the object in front of it, whether it's a pedestrian, whether it is a vehicle, whether it is a traffic sign, and so on. And accordingly, it needs to take actions. So in automotive, also classification is performed behind the hood in self-driving cars. Now let's look at another set of applications, right? And we are just getting warmed up. Now, another set of applications like sales and demand forecasting, right? Weather forecasting, marketplace forecasting, all of these, as the name itself has, these are all forecasting problems. And this is another subfield of data science. Sales and demand forecasting is where we are trying to predict the sales and demand of our products. And they have an annual potential value up to $18.5 billion globally, according to a McKinsey report. Weather forecasting is something we are all familiar with, right? This is going to be the forecast. It's going to be rainy tomorrow. It's going to be sunny at this time tomorrow, and so on. It's again a forecasting problem. Marketplace forecasting is somewhat interesting, where what you're trying to predict, what Uber actually in this case is trying to predict, is where should it place its drivers, right, and its cars, so that it is optimally satisfying the demand that is out there based on the supply that exists of its cars in the market. And this is a infogram of San Francisco and the nearby areas of Oakland. And it's basically showing, this visual is taken from Uber's website directly, where they actually mapped the demand and supply, and they are basically trying to forecast the marketplace as well. Okay, so very interesting set of use cases, and all of these deal with forecasting. And this is officially a subset of data science as well, where what we are dealing with are, so if you think about it, right, sales is also a continuous value, right? Marketplace can also be sort of a continuous value. But officially what we are dealing with is another set of data, which is called time series data, which has a specific time element to it, right? If you're forecasting sales, you're probably looking at 10 years of data, but it is time based, right? How does the seasonality of the sales occur, right? Over holidays, sales of certain products might be higher, right? Like entertainment products and so on. Weather forecasting, right? You're looking at weather information of the past few days and trying to predict, or past few years for that matter, and trying to predict what will happen in that particular area. Marketplace forecasting also follows the same approach. So this is another subfield of data science, and these are the applications. Now let's see a few more applications, right? Let's look at association rule mining, and this is a very popular application in the retail industry. So if customers are purchasing certain products in your store, right, what other products are they most likely to purchase as well. So if a customer, let's say for example, is purchasing milk and bread, most likely they are purchasing things for breakfast. So you might want to suggest that, okay, you should also purchase eggs along with that, because in a lot of transactions we have seen that customers who have purchased milk and bread have had eggs in their basket as well. So that's why it's called a market basket analysis, right? Looking at all the baskets of goods that customers have purchased, what are the association rules between the goods, right? And based on that, you understand the different association rules, and you can use that to recommend new items to customers who have put certain things in their cart, right? If you look at Amazon, if you look at certain books, for example, it suggests, these are often bought together, right? So that's again kind of an association rule mining application. Anomaly detection, right? Again, anomaly detection can also, it's also dealing with predictive maintenance. It's a slightly different problem, but again, you're trying to basically detect any anomalies, right? Anything off from the usual that has occurred. Now, if you think about these two problems, these are very, very different from what we have just discussed, right? There's nothing specific that you're trying to do, in the sense that you don't have a target. You don't have a target association rule that you are trying to get, or you don't have a target anomaly that you're trying to get at, right? So you're just trying to find patterns in the data, right? And this is another kind of a subfield of data science, which we'll talk more about. It's called unsupervised learning. Let's look at a few more examples of applications like clustering, right? Customer segmentation. This is often done in marketing, where you're trying to find out similar customers and pockets of similar customers so that you can better position and advertise where you have a lot of data, and you're trying to find the most relevant information out of all of that data. So what you're trying is you're reducing the dimensions of your data, and this will become clear, right? What do we mean by dimension? How do you reduce this? All of these questions will become clear when we are actually going deep into each of these applications. And that's what we will do over the next few sessions as well. And again, this is about finding patterns. So let's have a quick recap what we have done. We have gone over a few applications of data science, and there are many, many more, right? Like, we have not covered everything. All of these applications are dealing with structured data, right? Like tabular data, like numbers. But if you look at your mobile app and it's doing face recognition, that is another application of data science, which we'll cover soon, right? If you're looking at chatbots, that's another application of data science, right? Where you're just typing in something and it's responding back to you. But it's dealing with text data or image data. Here, what we have dealt with, we are dealing strictly with tabular data, number-based data, and this is the majority of data science is dealing with structured data, right? And that's why we have focused on these applications to start with. So we have covered regression applications, classification applications, time series forecasting applications, and then finally applications which just deal with finding patterns, right? So this is all we have for today. If there are any questions, right, I'll take them now. And I'll wait for a few seconds. You can ask any questions that you have, and we'll take them now. Else, see you tomorrow at 10 p.m. Okay, I see that there are no questions. So we'll meet again at 10 p.m. tomorrow. Stay tuned. See you tomorrow.